Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, I am Madam Maisarah. Today I would like to explain about Chapter 5, Function and Graph for Subchapter 5.4, Exponential and Logarithm Function. This is Lecture 4, Part 2. Learning Outcome. At the end of the lesson, students are able to find the composite function involving exponential and logarithmic functions. D. Sketch the graph which involve exponential and logarithmic function on the same axis. Relationship between an exponential and logarithmic function. Exponential function is f(x) equals to a power x. By using property, let f inverse is equal to x. So then a power f inverse is equal to x. Then we get f inverse of x equals to log base a x. Therefore, the inverse of exponential function is logarithmic function. The logarithm function is f(x) equals to log base a x. By using property, let f inverse is equal to x. So then log base a f inverse equals to x. So then f inverse is equal to a power x. So therefore, the inverse of logarithmic function is exponential function. So then we can conclude that exponential and logarithms are inverse of each other. This is the graph of exponential and logarithm function on the same axis. The blue curve is f(x) equals to a power x, while the yellow one is f(x) equals to log base a x. Both graphs are the reflection of each other about the line y equals to x. Thus, exponential and logarithm are inverse of each other. You can observe from this graph. Compute the composite function involving exponential and logarithm function. Example 3. Given that f(x) is equal to 2x plus 1 and gx equals to ex, e power x, find g of x and f gx. So this is the composite function of gf and f gx. So first we find g of x. G of x means that g 2x plus 1. So then we substitute 2x plus 1 into gx. We get e power 2x plus 1. Then f gx is f ex, means that we substitute ex into 2x plus 1, we get 2ex plus 1. Example 4. Given f(x) equals to ln x, find f inverse of x and sketch the graph of f(x) and f inverse of x on the same axis. First, we find f inverse. By using property f inverse is equal to x. So then ln f inverse equals to x. So then we e both sides, we get f inverse is equal to e power x. So f inverse here is exponent power x. Now we want to sketch the graph of fx and f inverse on the same axis. So first we draw f(x) equals to ln x. So then draw x-axis and y-axis. Then draw ln x. Since the domain is more than 0 and it has x-intercept x equals to 1 and the positive is in front, logarithm is positive, so then it's moving up. So the graph of ln x will be like this. Then we draw a reflection line y equals to x, and then we reflect f inverse So since fx has x-intercept 1, so then it's for f inverse it's become y is equal to 1, y-intercept. So then the graph is reflecting the graph of fx, so then it's become like this. This is f inverse equals to e power x graph. Example 5. Given fx equals to ln 3x plus 2, show that f is one-to-one function and find the f inverse of x. Sketch the graph of fx and the f inverse on the same axis. Okay, let's look at for solution. Example 5. For question A, we want to show one-to-one function. By using an algebraic approach, fx1 equals to fx2, ln 3x1 plus 2 equals to ln 3x2 plus 2. Then we e both side. Then we e both side. We get 3x1 plus 2 equals to 3x2 plus 2. And then it's become 3x1 equals to 3x2. Then finally we divide by 3. It implies x1 equals to x2. Means that f is one-to-one function. Then we want to find f inverse. By using property, let f inverse equals to x. So then ln 3 f inverse plus 2 equals to x. 3 f inverse plus 2 equals to ex. Then we bring 2 on the left hand side to the right hand side. We get 3 f inverse equals to e power x minus 2. So finally we divide by 3 until we get f inverse equals to e power x minus 2 over 3. Now for question B, we want to sketch fx and f inverse on the same axis. First, we want to draw fx. To sketch ln 3x plus 2, we must find domain. 3x plus 2 is more than 0, so then we get the domain x more than negative 2 over 3. Means that it has vertical asymptote at x equals to negative 2 over 3. So first we draw x-axis, y-axis, and vertical asymptote negative 2 over 3. And then fx has x-intercept x equals to negative 1 over 3. And in front of logarithm is positive, so means that the graph is moving up. So the graph would be like this for fx. The blue color, the blue curve is fx. Then we want to sketch f inverse on the same axis. So we need to sketch y equals to x, the reflecting line. Since fx has x-intercept negative 1 over 3, then f inverse has y-intercept negative 1 over 3. And then since fx has vertical asymptote at x equals to negative 2 over 3, so then f inverse has horizontal asymptote at y equals to negative 2 over 3. It's become terbalik. Then we reflect the f inverse graph would be like this. So this red one, the red curve is f inverse. Lecture 4 comes to the end. That's all for now. Thank you. Bye.